Okay, so we're going to talk about solving quadratics using the AC method. So you pretty much were at the point maybe in Algebra 1 where your teacher taught you how to factor if a leading coefficient of 1, and you may have gotten to solving, and your Algebra 2 teacher may have talked about leading coefficient of being 1 and how you would solve these, but now you're starting to get into ones where A is no longer 1, and you need a different method than maybe what was explained in class, or you just need a refresher on the way that it was explained in class. So this video is going to be on the AC method of solving and how we do that. So just a quick refresher of how we've done maybe these ones in the past right here. So these ones in the past weren't that bad because if the leading coefficient is 1, you're just looking at the terms of C, the factors of C that would make the middle term. So you should know that all quadratics break into a linear times a linear. So you have this first linear pair of x by x, and you only write x by x, presuming you're having just an x squared, so 1x squared. And now you're looking at the constant term, so you need to know the constant terms of a linear will make the constant term of the quadratic. So what do those two that make positive 9? So you have 5 times 4 makes 20. Well, 5 plus 4 also makes 9, so positive 4 and positive 5. And then when you go through and solve this, you would go x equals negative 5 or x equals negative 4, and you have the values that will give you the answer being 0. However, the problem is now you come to new ones that are a little bit harder, okay, and you've got this stuff that focuses on the A being a 3. So the method we're going to utilize here is something called the AC method. And in the AC method, okay, what you're going to do is you're going to multiply the A of your quadratic, okay, times the value of C. So the first step is to multiply those two together, so you get 3 times 40 and you get negative 120. Okay, so AC method is literally going to come from these terms in the quadratic in standard form or general form, however you're calling it. So ax squared plus bx plus c, where a is the coefficient of the squared term and c is the constant. Okay, so I'm going to multiply those two together. In this case, I make negative 120. Now, me personally, I also like to draw this x here because I'm going to put the 19 down there to remind me that I still need to make positive 19. So even though I'm making negative 120, I still need to find things that make positive 19. So then I'm going to start my process. I'm just going to start off with how the heck do I make 120? And the way I make that is utilizing factor pairs. So 1 times 120, and then I'll go, okay, 2 times 60, and I'm asking myself, can any of these make 19 somehow, some way, but still make negative 120? And so far, I don't have an answer. So then I go to 3, so 3 times 40, so 3 and 40 make 43 or 37, not 19. So I keep going, so 4 and 30, so again, 4 and 30 is going to make either 34 or 26, still not 19. So I go to 5, and I go 5 and 24. Okay, so I either make 20 or 29, or I can make 19. So there we go, there's my pair that I have, okay? So I can make 19 and negative 120, presuming that my 24 is positive and my 5 is negative, okay? Now, these two terms that I have here for the AC method are going to be used to decompose 19. So what does it mean to decompose? Well, simplify would mean to combine them. All right, decompose would be to write them back out into the two things you combined, okay, to make that 19. So I'm going to take 3x squared and I'm going to write it down as normal. So 3x squared. And instead of writing positive 19, I'm going to write plus 24x minus 5x minus 40 equals 0. So then from here, what I'm going to do, okay, is that now I'm going to utilize what we call the grouping method. So if I'm using the AC method, all right, I am also going to have to use the grouping method. And the grouping method is like this. You take the first two terms and group them, and you take the second two terms. Now, if there is a negative out front, you need to include that in your group. You cannot forget that in your group. It's extremely crucial, important that you do. So if it's a negative, you're going to have to put a plus sign in between your two groups after you group them up. All right, so then from here, what you're going to utilize is you're going to use GCF. So you're going to look at the numbers and go, what can I divide each one of those by? And in this case, 3, okay, goes into 3 and 24. You look at the variables. I can take an x away from both of them. So if I take 3 away from 3, I'm left with 1. I take an x away from 2, I'm left with just 1x. 24 divided by 3 is 8, so that leaves me 8 plus 8. Now that group has been done. I move on to the next one. Now you need to be careful about the negative out front. So you need to get this negative away from the 5. So in this case, we are going to factor out a negative. That's an extremely important piece here. So when I factor out a negative, that's going to be part of it. So I'm going to go ahead and factor out the negative. So we make this in red, so negative. But now I'm going to look at the numbers. So the thing that go into 5 and 40 is both a 5. Close that parenthesis out. Okay, now why didn't I put a variable this time? Because the first one has a variable, but the second one does not. So we're utilizing GCF. So we're utilizing an Algebra 1 skill right now, okay? So factoring out the group by the GCF. If you don't understand factoring by GCF, you may want to look up a video on doing that, okay? But anyhow, I factor out the negative. So negative 5 divided by negative 5 is positive 1x. Okay, and then I look at negative 40 divided by negative 5 makes a positive 8 equals 0. Now, the way that I know that I'll have done this correctly is that you see these two groups here, they should be identical. So if they're not identical, you've done something wrong. So again, we continue on because now I need to get this into a binomial times a binomial. So now what I'm going to do is I'm actually going to factor out the group that I just made from each. So I take away the group from each. So take away an x plus 8 from each. And what I'm left with, okay, if I take away x plus 8, the other group is going to have a 3x. And if I take away the x plus 8 from here, I'm left with negative 5. And that all still equals 0. So now, unfortunately, utilizing this method, we're still not done yet, because from here I now need to solve what is the value of x that would make this 0. So the process would be you take x plus 8, and say it equals 0, and you take 3x minus 5, and you say, hey, that could equal 0. And then from here you solve for x. So in this case, x will equal negative 8. And in this case, you add 5 to both sides, then divide by 3, so you get x is equivalent to 5 over 3. So then I am now done. So utilizing the AC method to solve these will, in fact, okay, take a little bit longer to do, so you need to be careful about that. So there's all my work just shown to you there. So remember, you will have to go through this process, and I will show that again on another one. So here. Okay, so now we're back to this problem. All right, so we want to utilize, all right, this a times 0 equals 0 property. That doesn't change no matter what we have. So in this case, the last video, we already had it equal to 0, but this time I have it equal to 4. So what I need to do is I need to subtract 4 from both sides. So I get 12x squared plus 5x, and 2 minus 4 is going to be negative 2 equals 0. So again, if I'm utilizing the AC method, I'm going to multiply the a and the c together. Okay, so the a and the c together makes negative 24. So now I'm going to look at the factors of negative 24. That will also add to make 5. So I look at 24. All right, so I go 1 and 24. 2 times 12, 3 times 8. All right, and then I'm going to stop. I'm not even going to worry about 4 and 6 because I already have what will make 5, which is 3 and 8. All right, I just need to make sure when I look at them, can I make negative 24 out of it? There may be a time you could make 5, but you have to make sure that you can make the top, the negative 24 as well. And in this case, that will work because I can use the 8 to be the positive and the 3 to be the negative. Multiply them together, you get negative 24. Add them, you get 5. So what I'm decomposing my 5x into is negative 3 and 8. So I get 12x squared minus 3x plus 8x minus 2 equals 0. So notice I decomposed 5 into 2 terms. That will make it. And then from here, I now do factor by grouping. So I'm going to group these two. Now, this 8x wasn't negative, so I don't need to include the positive. The positive and positive doesn't matter. So I factor those groups, and what I'm left with is, okay, so what goes into 12? That goes into 3, and that means 3. You can divide both those things by 3. I take an x out, and I'm left with 4x minus 1. And then I take a look at the second one, so I go, what goes into 8 that I can divide both 2 by? And since it's positive, I don't have to worry about it, so 8, and that would be the number 2. So 2 goes into 8 4 times. I get 4x minus 1. I know I've done this correctly because this group and this group match. So at this point, Okay, it's literally just a matter of factoring out that group. So I take the group away from both. I go 4x minus 1, so that group goes bye-bye, all right, from each one, and I'm left with my other group of 3x plus 2, and I say that equals 0. And then from here, I now solve each of them. So I would go 4x minus 1 equals 0, 3x plus 2 equals 0. Solve it. I add 1, divide by 4. I get x equals 1/4. Subtract 2, divide by 3. I get x equals negative 2/3. Okay? And then put a little or in between because I can't use them simultaneously. But there we go. I'm now done. So that one took a little less work because I'm doing a little less explanation. So I hope you understand that. Okay, so then we move to the last one. Now, AC method again. So I take a look at this and I go, okay, I've now maybe got bigger numbers. So again, we still invoke that idea of a times 0 equals 0. I still want to make that, so I need to have something that equals to 0. So I'm going to add 15 to both sides. I get 36x squared minus 61x. When I add 15 to the 5, that will now create a positive 20 that now equals 0. So here we go, AC method. I multiply the first term and the last term together. So when I take 36 and multiply it by 20, I now get a huge number. I get 720. So I must look at that now, and I now need to make negative 61, though, as well. So here is where I'm going to go through this just to show you where a possible downfall of the AC method is when you multiply those two numbers and they make a big number. But I'm going to go through the process so you see it in case you like this method and you want to utilize it. So here we go. I look at 720, and I would suggest having a calculator on this one. Okay, so you go 1, and you go 720, not making negative 61. So you go 720 divided by 2, and that is going to be 360, right? So 2 and 360. That's no way making 61. Okay, so then I'm going to go to 3. Does 3 go into 72? And the answer is yes. Okay. And the answer to that is 240. So I get 3, okay, and 240. All right, so I got to keep going. So I'm just going to move this over so you see this. Okay, so I'm focusing on this part. So does 4 go into 720? Okay, divide by 4. And I get 180. Okay, so I get 4 and 180. All right, so now I'm going to stop for a second just to show you a quick little hack because I just want to make sure that you see this so that you understand it. But you notice how the second column is all ending in zeros? Okay, so what I'm going to show you very quickly is a little hack just to check, do any of these make your negative 61 for you a little bit quicker. And one little hack you can utilize is you can just switch the 0 to the other number. So I get 10 and 720, blah. Okay, 10 and 72, not making the negative 61 still. Okay, I can have 20 and 36, not working. 30 and 24, still not working. And then I could add 40 and I could add 18. Okay, still not working. Okay, so we get back at it, right? So we do 720 divided by 5, and you get 144. All right, in this case, it doesn't end in 0. There's nothing I can do. But I now can do 720 divided by 6, and I get 120. Okay, so 6 and 120. So at this point, what I can do is I can go back to that 0 idea. I can do 60, and I can do 12. Okay, that's not going to work either. All right, none of those are making 61. Does 7 go into it? And the answer is no, 7 doesn't go into it. But does 8 go into it? And 7, you should know that 728 will go into it. Will go into it 90 times, right? And you get 90, right? So just making sure here. So then I get also, all right, I can switch them up. I can do 80 and 9, and I'm still not making 61. So I'm going to keep going, right? So I go, 9, does 9 go in? Well, we've already got that over here. That kind of take care of it. So I go to 10. Does 10 go into it? Okay, we got 72. So again, I'm still trying to make this negative 61, and at this point, it doesn't look like I've got it. So we try 10, we go to 11, to 720. Is that divisible by 11? The answer is no. So we do 720 divided by 12, and we get 60. All right, so 12 times 60. Okay, now we already had that before, so that's not working either. All right, so we keep going. Does 720, is that divisible by 30? And we get 24. Okay, so we have 30 and 24. We've already got that. How about keep going on, right? So we got to keep going. So we got to do 720, and we're going to divide that. All right, we're going to just keep going here. We got to make our numbers, so we got to go 15. Does 15 go into it? Okay, 15 and 48. So 15 and 48. Does 15 and 48, okay, does that work? 15 and 48, it's not working, right? So if you notice, this is taking a long time. This is the downfall to the AC method. All right, so 720, we got to divide it by 16 now, so 720 divided by 16, you get 45. So I've now got 16 and 45. Okay, so 16 and 45, can that make 61? And the answer is yes. 45 and 16 does make my 61, presuming that they're both negative. Now, if they're both negative, we're hoping that that is going to multiply to make a positive, and the answer will be yes, it will. So, finally, I get to go back to here, and I go negative 16 and negative 45 is what I'm going to decompose negative 61 down into. So if you notice, having my list organized makes things a little bit easier. But the AC method in this case, it does have a downfall when this number gets ridiculously large, okay? So if you stick to the process and you just follow through with it, eventually you will get to a number and you'll be okay. It may take you a little longer, but this is the downfall of the AC method. But anyhow, now we get back to it. So 36x squared, and we go negative 16x minus 45x plus 20 equals 0. And now I need to look at the groups, so I group them up. So 36 and this, group in that negative, can't forget it, put a plus sign in between them. And now we move forward. Okay, what goes into 36? That goes into 16. So we go, all right, what's going to go into them? And we go, okay, how about 9? Nope, 9 doesn't work. How about 8? Nope, 8 doesn't work. How about 4? Yes, 4 is going to work, right? So, So 4 goes into it, so I get a 4x. Close out that parentheses, so 36 divided by 4 is 9. All right, so I get 9x, and then 4 goes into 16, and negative 4 there. All right, so that's working nicely here. Again, just GCF. Now, you know you got the right number when you're left with two numbers in the group that you still can't have anything in common, okay? So then plus, so now here, be careful. I got to factor out a negative. It's very, very important at this time that I'm going to factor this negative out. All right, so I'm going to go negative. So what now goes into 45? That also goes into 20, and the answer to that is 5. So I'm taking a negative 5 out, and I'm left with 9x, so negative 45 divided by negative 5 is positive 9, and 20 divided by negative 5 is going to be negative 4. Okay, and I still say that all equals 0. And then from here, again, I'm taking this group away, so I get 9x minus 4 times the group. Okay, what's left? If I take that away, I'm left with 4x minus 5 is equivalent to 0. And then from here I can now solve. So 9x minus 4 equals 0, and 4x minus 5 equals 0. So in this case I'll get x equals, add 4 to both sides, divide by 9, I get 4/9. In this case, add 5 to both sides, divide by 4, I get x equals 5/4. And then I'm finally done. I have my two answers. So x equals 4/9 or x equals 5/4. So this was a long one. The last one's a long one because the number was really large. But if you stick at the process, the AC method does work. But this one I'm just demonstrating to you was a downfall of it. It took a little bit while, and that's why I said you wanted to have a calculator with you just to check that the numbers go in, because 720 is a larger number. But if you notice, I just went down the list in order. I went 1, 2, 3, 4, 5, 6, and then 7 didn't work, so I skipped over it and went to 8, okay? So if you just keep following that process, you'll be good to go, and that's how you'll do the AC method, all right? So I hope that helps.